In the world of data streaming, you hear this promise that sounds, well, almost too good to be true. Perfect, flawless data delivery. We're talking no lost messages and zero duplicates. Now, for systems that handle things like financial transactions or critical inventory, that's the absolute dream. But when it comes to Apache Kafka, is this promise just a myth, or is it a reality we can actually build on? Let's dig in and find out.
So yeah, that's the big question we're tackling today. We're going to go on a little myth-busting journey to see if exactly once delivery is something you can really count on in the messy, real world of distributed systems, or if it's just a nice idea that lives on a whiteboard.
Okay, before we get into the nitty-gritty of how Kafka pulls this off, let's just take a step back and ask why. Why is exactly once considered the holy grail of data streaming? What's the big deal?
At its core, exactly once semantics, or EOS for short, is this really simple but incredibly powerful guarantee. I mean, think about a banking app, right? You would never want your payment to get lost, and you definitely wouldn't want it to be charged twice. EOS is what makes sure that what you send is what gets processed, and only once.
You know, to really appreciate exactly once, you have to see the alternatives. On one hand, you have at most once delivery. It's fast, but if there's a network hiccup, poof, your data could be gone forever. Then there's at least once. Here, you won't lose data, which is great, but you might get duplicates from retries. Exactly once is that perfect middle ground, that sweet spot. No loss, no duplicates. That's what we're aiming for.
So how does Kafka, one of the biggest names in data streaming, step up to the plate? Well, when Kafka first claimed to support EOS, there was, let's say, a healthy dose of skepticism in the developer community. And for good reason. This is a notoriously difficult problem to solve.
But then, Kafka version 0.11 dropped. And this wasn't just some minor update. It was a total game changer. It took this complex, almost theoretical concept and baked it right into the platform, making it a practical feature you could actually use.
Now, Kafka's solution isn't some single magic bullet. It's a really robust system that's built on 3 core pillars, all working together perfectly: idempotent producers, atomic writes, and some very smart consumer offset management. So let's break down each one.
All right, so how does the magic actually happen? Let's pull back the curtain and really get into the clever engineering behind each of these 3 pillars.
First up, let's talk about the producer. That's the part of your system that's sending messages into Kafka. The big challenge here is to stop the producer from accidentally sending the same message twice, which can happen all the time if it has to retry sending after a temporary network error.
And the solution is pretty slick. An idempotent producer attaches a unique ID and a sequence number to every single message. So if a producer has a problem and tries to send the same message again, Kafka just looks at the sequence number, says, hey, I've seen this one before, and just throws the duplicate away. This is our first line of defense against duplicates.
Now for our second pillar, atomic writes, which you'll usually hear called transactions. This pillar tackles a much trickier problem. What happens when your application needs to write to multiple topics or partitions all at the same time?
Kafka transactions make sure that a whole batch of messages is treated as one single all-or-nothing operation. This is absolutely crucial for keeping your data consistent. It means you'll never end up in some weird partial state where only some of your messages made it through. It's either a total success or a total failure, no messy in between.
Okay, last but not least, our third pillar takes us to the other side of the equation, the consumer. We've made sure messages get into Kafka perfectly. Now, how do we make sure they're processed correctly, and only once?
This is all about keeping a really good bookmark. The consumer processes a message, and only after it's completely finished does it save its position by committing the offset. This marks the message as done. So if that consumer crashes and has to restart, it just looks at its last bookmark and knows exactly where to pick up, which prevents it from accidentally reprocessing messages it already handled.
All right, the theory is great, but how do you actually make this work in your own applications? Let's shift gears from the what to the how and look at a practical playbook for implementing this.
So, at a high level, the steps to get EOS working actually mirror the 3 pillars we just talked about. First, you configure your producer for idempotence. Second, you wrap your logic in Kafka's transaction APIs. And third, you make sure your consumer is set up to handle its offsets as part of that transaction.
For all you developers out there, you might want to screenshot this slide. This is basically your cheat sheet. First, you set enable.idempotence to true. That turns on the deduplication magic. Next, you have to give it a stable transactional.id. This is super important because it lets Kafka keep track of your producer even if it restarts, and it prevents so-called zombie producers from causing chaos. And finally, on the consumer side, you have to set enable.auto.commit to false. This gives your app manual control, making sure that read, process, write cycle happens as one atomic unit.
Of course, a guarantee this strong doesn't come for free. It's really important to understand that when you enable exactly one semantics, you're going to introduce some overhead. All of that extra coordination and tracking has a bit of a performance cost.
So where does that overhead actually come from? Well, it's things like the extra network trips to coordinate the transaction, the extra work the broker has to do to check for duplicates, and managing all the transaction markers. You're basically trading a small slice of raw speed for a massive gain in data integrity. It's a critical trade-off you need to think about and monitor for your specific use case.
So after all that, after looking at the mechanics, the implementation, and the trade-offs, where do we land? Is exactly once in Kafka a myth?
The verdict is in, and this quote from our source material says it perfectly. It's not a myth. It is a sophisticated reality built on layers of really careful, deliberate engineering. It's totally achievable, but you've got to understand how it works under the hood to use it right.
Okay, let's boil it all down. What are the big things to remember? First, EOS in Kafka is real. It's made possible by that powerful trio: idempotency, transactions, and offset management. Just remember that it requires very careful configuration, and you always have to be mindful of that performance overhead.
And that leaves us with one final, exciting question. Now that you know how this is done, now that you know this powerful guarantee is within your reach, what will you build with it? The possibilities for critical, data-sensitive applications are pretty incredible.